then sort of Pranav. Pranav, are you able to do lower bound, upper bound functions? Okay. Okay. Good. Anyways, I'll drop a code for that. Both the code from scratch and as well as the C++. I'll drop a code. So whoever have done it, very good. Whoever are not, you can just look back and see if you have made any mistakes. Okay. So let's get into our today's class. Yesterday, on the previous day, we have discussed about recursion, how recursion stack works internally, how to visualize a recursion using trees if there are two children or there are multiple children, how to visualize them, how internally it works, how local variables work, and in general, what is the idea of recursion, where to use recursion, what are the important things which you have to keep in mind for a recursion, all these things. And I have also asked you to experiment about taking different branches of the tree, seeing the output, dry running the code and checking your output with the original output. Did anyone attempt that part? Did you try writing a basic recursive code and seeing whether your dry run output and the code output matched? Okay, Saurav says yes. I mean, the three important concepts which we'll be discussing is like this recursion. Recursion, we have already discussed about. We have discussed about searching techniques, and we'll be discussing about sorting techniques also. These three are, I would say, the very building blocks of DSA. If you know these things, when we go to remaining data structures, things will become very simple. These three are very important, and a major section of problems span over these three concepts. And obviously, then you'll have DP. We'll discuss about DP also. Okay, Kapil and Saurav says here. Yes, what about remaining people? Rashmika also says yes. Ashish says yes. Okay. Okay. Cool then. If not, it's highly recommended that you go dry run your code, because it's very important to understand what is happening to recursion internally. Okay. When we go to higher level codes, it will be very difficult to debug if you're trying to dry run a complex recursive code. If you have dry run and understood how recursion works for a small code, then you need not dry run for bigger codes. You'll automatically get the idea. So that's the reason, and make sure you practice those things. And let's come back to today's class. And today's class might be a little lengthy, so let's start our class. Okay, I will solve one more problem on recursion and then move to the next topic. Okay. So the question is, Sachin, I did, but I don't know. I did it in a right way or not. So to check whether your understanding of recursion is right or wrong, whatever the code you're trying to dry run, code the same on some platform. Code it in VS Code or code it in CPP, C++, whatever you want. Code it, dry run that code. Compare your output with the output of the code. Then you'll understand whether you're thinking it in the right direction or not. Okay. Yeah. So our question is, given an array, print all the subarrays. What does subarrays means? They are continuous chunks.
Hello. हाँ भैया.
Okay. Continuous chunks of the arrays.
हाँ भैया. हाँ भैया 75 है सूर्यनगर नाड़ी का फटक भैया.
So how will we do? First, let's discuss a very
75.
very very naive approach. Then let's try to optimize that approach. Okay, go ahead.
ये अपने नाड़ी का फाटक है ना, तो नाड़ी का फाटक से आप किधर की तरफ से आओगे?
I'll give you 5 minutes to think. Or just first we'll discuss about the naive approach. After naive approach, we'll discuss about the
फाटक है ना, क्रॉस मत करना, तो जो गली जाएगी उस गली में सीधे सीधा जाना. फिर है? हाँ वो फ्रीज रखा हुआ है, वाटर कूलर रखा हुआ है उसी वाली गली में. थोड़ा सा अंदर आओगे ना तो ऋतिका फोटो स्टूडियो आएगा. हाँ और उसी 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 गली में सीधा सीधा उसके बगल में गली जा रही है, सीधा सीधा आ जाना, 75 नंबर का प्लॉट है।
Any other ideas? Oh, if condition? Okay.
हाँ हाँ
What about remaining people? Ankit, I did not see you on
ठीक
the
है ठीक
pitch
है।
today at all. Where are you? Are you there? Is Ankit in the class? Okay, cool. If condition nested for loops, yes, Rashmi, Palak, okay. Okay, let's look into. So, what is the main thing for a subarray? It has a subarray is a part of the array, so it will have some lower and upper bounds, or say starting and ending points. We have to create these boundaries. Okay. So, for creating two boundaries, let's iterate from. For two boundaries, let's have two for loops. I is 0 to n minus 1. For j is equal to your subarray can contain one element also. So iterate j from this current I value to n minus 1 values. Now, in the third for loop, let's take one more variable. Iterate from j to a, print all the elements. One execution of this for loop will print one subarray, and overall all the changing different bounds will produce different subarrays. Okay. Yeah. So any doubts in this algorithm? Okay. So no, if you understand the okay, no. Okay, Ashish, Rashmi, okay. Okay. Bikash also says no. Okay. I'll wait for 2 or 3 more answers. Okay. Oh, Animesh, Shivangi. Okay. So, what is the time complexity of this algorithm and space complexity? Ma'am, what to write in this for loop? If you mean this particular for loop, you basically write for k is equal to I, k less than or equal to j, k plus plus, sorry, k is equal to I, print ARR of k. Print so on, you will get one subarray. Okay, done. What is the time complexity of this algorithm? Yeah. One n iteration for the outer for loop, in inner iteration another n, and for the printing the values and another n. So it will be O of n cube. And what is the space complexity? Yes, we are not using any extra space, we are just printing the values. So the space complexity will be O of 1. Yes, Ankit right, Saurav right. Yeah, Vishal right. So, is there any other approach to solve this problem? Think for 5 minutes, then we'll come back. Only 2 for loops. Can you send me any pseudocode for that, Saurabh?
हाँ भैया, उसके बगल में गली जा रही है।
Think for 5 minutes. I'll give you. Meanwhile, I'll be giving you small hints. Ma'am, repeat M1, please. Okay. So, to repeat M1. So the main thing for a subarray is a contiguous part of a array. If it's a contiguous part, if you know start and end element, you can print all the elements in between. So the main thing which you have to pinpoint for a subarray is the starting point and the end point. Given a starting point and end point, you'll get the subarray. To get the total number of subarrays, you need to generate all the permutations and combinations of a start point and end point. Okay. To generate every start pointer and every end pointer, we have to do two loops, which will span, I will span from 0 to n minus 1, j will span from I to n minus 1. I because we have to consider the elements of size 1 also. Okay. Then you have bounded both your start and end pointers. Now within the start, whatever elements are present within that particular start pointer to end pointer, print those elements. If we try to dry run this algorithm, what will happen? Let's say suppose arrays 1, 2, and 3. Okay. My I will span from 0 to 2. Okay. For j is equal to I to 2. Okay. So what will happen when I is equal to 2? First step, I will be equal to 0, j will be equal to 0. So print elements from 0 to 0. So it will print 1. Next, my I is equal to 0, j is equal to 1. It will print 1, 2. I is equal to 0, j is equal to 2. It will print 1, 2, and 3. Okay. Now my j is equal to 2. This for loop is over. So it will go and update the I. So I will become 1, j will become 0. Then it will print 2. Okay. I is equal to, then still I is equal to 1. J is equal to, sorry, 1 minute. We did a mistake. We did a mistake in dry run. So I is equal to 1. Then j will start from I. So j is also equal to 1. It will print 2. Then I is equal to 1. J is equal to 2. So 1 to 2, it will print 2 and 3. So it's basically 0, 1, 2. Okay. Then I is equal to 1. So j is equal to 2. This loop is done again. It will go and update the I. I will become 2. J will start from 2. It will print 3. Okay. It has printed 3. And now j is equal to 2. This loop is done again. It will go to 2. I will run between from 0 to 2 only. I loop is also done. It will exit from the entire condition. Is that clear? Okay. Okay, great. So, our task is, suppose if we have, say we have, let's say we have 5 elements. Here 3 elements are there. Here 2 elements are there. If we generate subarrays for these 3, for this 3 element array, then they are also the subarrays of 5 element array. If we generate subarrays of these 2 element array, then they are also subarrays of the 5 element array. Okay. If you see, there is a repetitive task here. So if you keep on generating for smaller arrays, you'll get the subarrays of the bigger arrays. Okay. In such cases, can we use recursion? Because whether it's a 3 element subarray or 2 element subarray, yes, subarray or subarrays, exactly. 3-element array will be the subarray of 5 array. So its subarrays are also subarrays of a 5-element array. Okay. So the basic thing is, so when we are able to boil down that one and solve it, I mean, when you're able to visualize something sort of a tree, you can go with recursion. Okay. Then, okay, fine. We have realized that, okay, we can solve the problem by recursion. But how do we solve that? What are the main things which we have to bound? We have to bound two different things. Okay. We have to bound the starting point and we have to bound the ending point. How do we pass different start and end points? Start and end points to recursion, such that there won't be repetitions and it will be as optimized as possible. Such that it won't repeat, as well as there won't be repetition, as well as there will be optimizations. Okay. Think for 2 minutes and let me know. But I'll be giving hints to you, so keep thinking. Take my hints in between, think more. Jagdish, good afternoon. So Jagdish or whoever have joined the class just now, so we are discussing about how to generate subarrays of a given array. Divide the array in half for the first time. I is equal to 1, j is equal to 1, stop at I equal to j. Ashutosh, very close. So one question which I'll ask here is, do we really need to break the array? Or should we move sequentially to solve the problem? Maybe say, I'll generate subarrays of this given array, then I'll move here, then I'll move here, then I'll move here. Can we do it in this way? Maybe using 2 pointers. Yes. So, can we combine the idea of 2 pointers plus recursion and pass these 2 pointers into the recursion function? Okay, Ashutosh says yes. What about remaining people? Start always at 0 and then n plus plus. Okay, good. Okay. So Saurav's part will move the front pointer. What shall we do to move the C? So your, the part, yes, your answer is correct for a part of the question. But let's see. Suppose we have answers 1, 2, 3. If we keep the start like that and keep moving the end pointer, we'll be able to generate these 3 arrays. But we also need to generate 2 and 2, 3. What shall we do for those things? Can from this element move the start pointer to generate this one, and move from this array move the start pointer to generate this one. Move start to generate these arrays. Saurav, did I make sense? Okay. And from this array, if we remove 2, we'll be able to generate 1 more 3 also. So we have to move start pointer, we have to move end pointer also. Till when we have to move our start pointer and end pointer? Till when we have single element, we need not move our start pointer. When single element is there, we need not move our start pointer. Okay. And suppose we have reached 1, 2, 3. Our endpoint has reached here. Then also we need not, ma'am, not get it. Yes, I'll repeat. Don't worry. Okay. Suppose we are at 1, 2, 3. Then also we need to stop. Because 3 is the last element and there is no point going beyond that. Okay. So, did I somehow write the terminating conditions of the recursion function? Okay. So, till now, how many understood what I was trying to say? How many did not get it? Let me get a quick one. Quick one. Whoever understood, type yes. Okay, Jatin says yes, Kapil says no, Jagadish Sharma says no, okay. Okay, Ashish also says no. So that's a good number of no. So let's set it. Okay. See, we have an array 1, 2, 3. Our task is generate all the subarrays. Okay. If you generate all the subarrays of 1, 2, let's say they have some X number of subarrays. They are also the subarrays of 1, 2, 3. So when you have such a kind of building thing, when you are able to build things, from smaller parts, when you're able to get to a bigger part, and which is your answer, then we use recursion. Clear till here? Did you understand this idea? Why are we using recursion for this particular function? Okay, Sachin says yes, Prabhojit also says yes. Okay, cool. What are the 2 main important things for a subarray? Start and end. We need not care about the middle elements because subarray is a contiguous part. For a continuous part, if you know the starting and ending point, you can print all the elements in between them. So, 2 important things for a subarray is the start and end. Start and end pointer. When these 2 are the important things, you have to send your recursive function these 2 inputs. But for this recursion, you have to send all the possible start values, all the legitimate start values, all the legitimate end values to generate all the subarrays. So, pause all the possible start and end values have to be same. Okay. Let's think on how to do it. Okay. Suppose if I ask you to generate a subarray, how will you generate it? Don't think about code and anything. How will you do it? Think about that one, mentally think about that one. Then we'll try to organize and put that one into code. Okay. My subarrays are like, suppose first I'll say my subarray is 1, my subarray is 1 comma 2, my subarray is 1 comma 2 comma 3. So for all these three elements, start is equal to 0, end pointer kept on increasing. Right? No. But all my subarrays are not generated. Now here there is only one element, so no more subarray, no more subarrays are possible from this one. But here I have two elements. There is a subarray possible. So let me say I want to move a start pointer here.
भाई उसने बताया था कि बाहर का लगा लो एक, पर आप बोले पैसे उसने बताया था कि पहले तो 750 लगेंगे,
and end pointer I leave it the same. End pointer is still at. Okay.
उसने बताया था
Then what subarray I'll be able to print?
आप मना करते हो, 1000 रुपए वाला बताया था उसने पहले आपको, मना करते
after 2 there are no more subarrays which I can generate. I'll remove that.
उसने बताया था.
Here my start pointer is 0, end pointer is 3. Then again I'll say move your start pointer plus plus.
बोला था उसने.
Then my start is equal to 1.
अरे 1000 वाला किसने बोला था, आपने मना कर दिया.
Then I'll be able to generate the subarray 2 comma 3.
भाई उसने उसका
Now still I have two
बात थोड़ी सी
elements.
बात ना, आप
From
चुप
this
हो
I can
जाते
generate
हो.
more subarrays.
उसने बोला था आपको पहले की बात.
Then, but my end pointer has reached its maximum. I cannot move my end pointer. I'll do my start pointer plus plus. Then my new start is
पूरे
equal
खराब हो गए,
to
तब तो लास्ट मोमेंट आ गया उनका, और वो तब
and
थोड़े
end
बहुत
is
और
equal
चलाओगे
to
तो
3.
और पूरी खराब हो जाएगी.
Actually, to be more precise, start is equal to 2, end is equal
गंदा
to 3.
पानी, गंदा पानी पिएंगे फिर.
Sorry, both are at 2. The start is 2, end is 2. Then I'll be able to generate the subarray 3. Single element, no more subarrays can be created. Okay. Now you see, you have got 1, 2, 3, 4, 5, and 6. Are these 6 subarrays the same as the 6 subarrays which we generated using the naive algorithm? Okay. Now did you get the idea on how to move the start pointer and end pointer and generate? See, here we have stopped when what did you do? Stopped when end pointer reached the end of the array. Okay. That's one stop condition we used. What is the second stop condition we used? Stop conditions. Okay. When did we stop? When there is a single element in the array. When there are no more elements. These are my stop conditions. My recursive code is, to recursive code I have to send an array, I have to send start pointer, I have to send an end pointer, I have to tweak these values according to the stop conditions. According to the stop conditions. Okay. So the two important things for a recursion are your stop conditions and the recursive algorithm. Not in terms of code, but in terms of the idea, did you get the idea? I mean, in terms of idea, did you understand what we'll be trying to do in the code? Okay. Sachin says yes. Prabhojit, Jatin. Okay, cool. Saurav also says yes. Okay. What about remaining people? I'll still wait for a few more S's. I'll give 2 minutes time so that everyone will try to grab this one, and then we'll move to code. Okay. What about remaining people? Ankit, what happened? Okay. Ashish also says yes. What about Ankit? And then we have Lahari, Pragati, Ravi Shankar. Did you understand now? Jagdish, did you understand now? Okay. Rashmi says understood. Okay. Jagdish. Okay. Ravi Shankar also says yes. Okay. Okay. Cool. Okay. Then now let's try to code. Okay. I'm just printing. So my return function from this function will be void only. Print subarrays. Okay. My input is ARR. I'll give you a start element. I'll give you an end. Let's say I'll give you one vector, start pointer, and start index and end index. Okay. If my end pointer is equal to my vector size. So basically I'm saying when my end pointer has become 3. 2 is also fine. 2 also I can generate. But my vector, okay, let's keep dry running for this example only, 1, 2, 3. When my end pointer is there, stop. I don't want any more recursion children from this particular function. So then I'll say return. Do nothing and return. So we have written one, this termination condition, we have put it into code. What is the other termination condition? Single element. When there are more elements, stop. Okay. Single element when okay. Let's write one more condition. Let's write a simple condition. Okay. Else if. Okay. Else. Let's say we have to. We'll keep generating these things sequentially. Okay. One condition is when you have one element left, then go back. So indirectly, so we'll try doing code as we have one. There are no more errors to generate. So we have more an endpoint. Okay, we have one more. We'll have 3 conditions to solve. For one thing, we'll move start pointer. For the other, we'll move an endpoint. Let's say we have moved endpointer. Okay. Okay. I write such that you will not have any confusion. Okay. Let's do it. Let's say here I did print. I'm calling this recursive function. I said print subarray. Take the same array. Do it as start plus 1 and pass the endpoint. Keep the end same, move the start. That's basically this condition. When you have 2 elements, we have moved the start pointer, okay, to generate the single to array. That condition I have written here. Here what I'll say is, this is like a single branch recursion only. At a time, we'll be using smaller subarrays to generate bigger subarrays. But from one parent, we don't have 2 children. So they are basically, this is a single branch recursion. Okay. In case of that single branch recursion, at some point, let's say my start pointer has become greater than the end pointer. See, because we have been calling this function continuously. We have been incrementing the start pointer continuously. But say your start pointer has crossed the end pointer. Then what we'll do? Reset the values. It means that you took one subarray. You have fixed your end pointer. You have moved your start pointer enough to generate all the subarrays. Okay. Then what we'll do is, once, let's say, okay, this is done. Then what we'll do? Reinitialize your start pointer and move your end pointer a little bit to generate the next. Okay. If start pointer is greater than the end pointer, then I'll say print subarrays, go with ARR, bring back your start pointer to 0, increase the scope of your function, make it n+1 and run. Okay. This is something, here we are initializing a new subarray, so we'll not use print state, we'll not use any print statement here. But when it comes to this condition, we'll say for I is equal to start to I less than or equal to end, I plus plus print ARR of I. And after the entire thing is done, do an end line so that we'll be able to differentiate between different subarrays. Okay. Did everyone understand the function? Yes or no? Okay, Saurav and Ashish say yes. Okay. Little bit confused. Okay. Let's try to dry run and then check if you understand it a little bit better. Okay. Let's say our array is 1, 2, 3. Okay. So from the main function, my initial start pointer is 0 and end pointer is also 0. I'm starting with 0, 0. Okay. Let me start with 0, 0. Let's say this is condition 1. Let's say this condition is 2. Let's say this condition is 3. Okay. Cool. I have 0, 0. Okay, if my end is equal to ARR of size, my array size is 3, end pointer is still 0, so this will not return. It did not satisfy this condition. One more thing also let me do. Let me write a return statement here. Return from this function. Okay. We have 0, 0. Okay. Then first condition did not match. Start pointer is greater than end pointer? No. Okay. Then else condition. What to do in else? Start less than or equal to end, print to that end. 0, 0. Start from 0, end with 0, print to that end. So I'll be able to print this subarray. Okay. I've printed this subarray. Then what did I do? ARR is equal to start plus 1 and send end pointer. So I did 1, 0. 0. This function I've called, from this function I've called this function. Then, if I call this function, a new function is invoked. Okay, this template is again invoked here. When the template is invoked, if condition, end value is 0, ARR of size is 0, then I would say, if ARR of size is still 0, then I would say return. But this condition did not match. What is my second sense? Start pointer is greater than end pointer. Yes. Here, third condition was met. Here third condition was met. Here second condition is met. When second condition is met, what will be my new again I'm invoking the function. What function I'm invoking? I'm initializing my start pointer, but I'm increasing my end value. I've invoked the function and there was no print. It did not go into the print function because it's the second condition. Now I have 0 end value. So first condition will fail because array size is 3. Second condition will be false because 0 is not greater than 1. I went into third condition. If it's a third condition, there will be a print statement. So what it will say? Start from I is equal to 0, I less than or equal to 1, print all the elements. Then it will print 1, comma 2. Okay. Then what it will do? It will do start plus 1 to end. See. Start plus 1, end remains. So here observe what is happening. Here, basically this is happening. I was at 0, comma 1. I was at 0 and 1. There is a scope to move the start pointer F1. If the start pointer moves beyond the scope, I'll exit in these conditions. Okay. Now I have 1, comma 1. Then let's see which condition is met here. So first condition will not be satisfied. Second condition is not satisfied. Again, it has gone to the third condition. If I go into third condition, what can I print? I can print 1, comma 1, start from 1, end at 1, print to that. Done. Very good. Then again I'm invoking one function. What is that? ARR of start, and I have to do start plus 1. Start is 1, plus 1 is 2, and then end remains the same. Okay. I'll stop for a minute here. Is it clear? Is the dry run okay? Are you able to get the dry run? Okay. Great. Okay, good. Okay, good. It's 2, comma 1. 2, comma 1, the function will start again. First condition did not get satisfied. Second condition, yes. It went into the second condition. If it went into the second condition, what will happen? I have to again restart my starting pointer. Then I would say I have to do n plus 1. I did 0, comma 2. And till now, if you observe, these 3 are the subarrays of 1, comma 2. Agreed? I'll wait for a few more yeses and then I'll proceed forward. Okay, great. Now I went to 0, comma 2. 0, comma 2 is a new function which I've invoked. First condition, not satisfied. Second condition, no. 0 is not greater than 2. Then third condition. If there is a third condition, I'll have a print statement. What according to print statement? Print from 0 to 2. 0, 1, 2, and 3. Done. Then what? Here I went into the third condition. Third condition, what will happen? Start plus 1. Start plus 1 is 1, comma 2. Okay. Start plus 1. I went inside. So again, new function is invoked. First condition not satisfied. Second condition not satisfied. Again, it has come to third condition. If it has come to third condition, it will print elements from 1 to 2. So 2 and 3. So it's basically 0, 1, 2 and x. So 1 and 2, 2 and 3 will be printed. Then next, third condition. If it's a third condition, what function will be invoked? Start plus 1 to end. What is start plus 1? 2, comma 2. Then again, go back. Give me a second. Okay. Start 2, comma 2. First condition is not satisfied. Second condition is not satisfied. It will come to third condition. If it comes to third condition, it has printed 3. And it has called which function? It has called 3, comma 2. Okay. It has called 3, comma 2. If we call 3, comma 2, first condition is not met. But second condition, yes. Start pointer has moved beyond the end pointer. So it went into the second condition, which has no print function. Then what will happen? We will initialize from 0 to 2, comma 3. So again functions invoked 3. What is our array size? Our array size is 3. Now my end pointer is equal to array size. Then I will say okay, return, done. This return will go back here, go back here, go back, go till here, go back to main function. Because if you observe, after every invoke of the call, there are no more statements to execute. Here also it will return. From if else it will come out, it will return here. From the statement it will come out, it will return. It will just go back straight away and return. So this will be a single branch recursion only. And if you see, you have generated 1, 2, 3, 4, 5, 6. You have generated all the subjects. Okay. Is it clear now? Lalit says clear. Rashmika also says clear. Sachin says yes. Okay. Okay. Ashish also says clear. With dry run it became easy. Yes. So when you write the code also, when you do something, so when you think you're going wrong in some way your code, if you dry run, if you understand your idea, if you put your algorithm into words properly, dry run, write the code, you'll be able to solve the things. What about remaining? Ravi Shankar, Pranav, Jatin, Animesh, Pragati, sorry, Lahari, and then Jagadish, Vishal, Prabhojit, Kapil, Ashutosh, I accept the request of Tanuj. Okay. Okay. There is no waiting room for this function. Why are people waiting? I mean, for this meeting, there is. Not at 12. Sachin, what is happening? I did not get that one. Accept the request of Tanuj Verma. Today I see only 60 people in the class. I think strength is 70. We send an SMS on LPU Live, ma'am. Oh, okay. What is LPU Live? I did not get that word. Okay, maybe group. Okay, am I in that group? I mean only your CES9 group. That's it. No, not in any other group. I think maybe Anup sir will handle that one. Okay, cool. Okay then. Did everyone understand this recursion and how this recursion works? So now, if I give you a question, will you be able to decipher whether to use recursion or not? Once you realize you have to use recursion, how to proceed, how to write the stop conditions, write the recursion expression, and then write the code. So everyone, does everyone have better clarity on recursion? Okay, am I on mute? Hello. Type yes if you can hear me. Okay. Cool. So everyone in the class now, do you have a better understanding of recursion? That was my question. Okay. Lalit says yes. Sachin yes. Pranav yes. Okay. Kapil also yes. Sachin also yes. Okay. What about remaining people? Animesh. I mean, we'll be moving to the next topic now. So I just want to be sure if you have any doubts. If not, we'll move to the next. If you don't have any doubts, yes, we'll move to the next part. So recursion complexity. Okay, complexity. Okay, let's discuss. The complexity of the code. See, we are calling all the possible values. It's okay. And if you see the recursion tree, we are calling n square recursion functions. Okay. And in each n square, there might be an n operation because you want to print it. The complexity will not change, but the way you approach the problem is only changing. Ashutosh, got my point? Okay. I have a question. Can we do this? Type the message out. Keep typing, Ashutosh. I'll give you a message. Okay. So the homework will be, we have printed subarrays of a given array. Now the next task is print subsequences. What is the difference between subarray and a subsequence? Subarrays are contiguous elements of an array. Subsequences are not. Rather, they will have elements in the same order as the input array, but few elements might be missing in each subsequence. Few elements might be missing in subsequences. Okay. So it's basically like you have 5 elements. Which do you want to put, which you don't want to put? Okay. Basically, it's like a binary representation. Given an array elements, you say 1 0 0 1 0. These 3 elements are there. This element is not there. Whatever ones are there, they form one subsequence. If you have 0 also, these 3 elements are the sequence. So everything can be 0 and 1. So that there'll be 2 power n subsequences. Including the empty and the original array. Okay. Generally, empty array is not considered a subsequence. So given an n array, we have 2 power n minus 1 subsequences. Can we solve this problem using recursion? If yes, what are the conditions? What do we need to? Yeah, subsets in another way. Subsets can be in any order. The subsequences is that the order is also fixed. Obviously, subsets, if they are duplicate, you'll remove them. But specifically, this term in a programming language is called as a subsequence. Can this be solved using recursion? If yes, what are the conditions? Think about this problem and solve. Okay. Yes, like subsets. Yes. Divide in half. Now loop. Again loop. Okay. So Ashutosh, for your question, if you break the subarray and generate subarrays independently, then think about whether we will be losing the subarrays of this particular element. Like 1, 2, 3, 4. We have break them. 1, 2, 3, 4. But in the process, will we be able to generate the subsequences of 1, 2, 3? That's what the for loop for. Okay. So easy or not for loop like 1, 2, 3, 4. Okay. Ashutosh, give me 1 minute. I'll unmute you. Oh, you can unmute and speak. I'll ask in WhatsApp. Cool. That's also fine. So try to code the subarrays problem, because almost the code is ready. You will just have to put it in your C++ editor. That's it. Okay. And then solve the subsequences problem also. Few more problems on recursions will be there. Once sorting is also done, then problems on searching plus sorting will be updated. Okay. Okay. We'll move to the new topic, sorting. Okay. As when we were discussing about the binary search also, we were discussing why it is important to search a particular thing. All your algorithms, any other complex algorithms will be in those lines only. Find something, search something, find the path, find the shortest path possible. How will you go about those things and all? So search is something which is very, very important. We have observed the difference between a linear search and a binary search. How much difference? How much difference an ordered data could make? So linear search was taking off n time, binary search was taking off log n time. For a small n, this log n might be very, very similar. But when we go to very, very higher inputs, like say 10 power 6 or something, so the complexity is going to reduce exponentially. Okay. And we have also discussed for search that two important things. Search key is important, search space is important. Key we cannot change. This is a user given input. But your search space, how sophisticated is your search space? How to make your search space in such a way that your searching later will become easy. Okay. Suppose n, obviously, when it's sorted, when it is arranged in a particular way, your search will become easy. Till now, we have been using the sorted array as a black box, or we have been taking default keys. Okay, these things are sorted for problems we need. But what if you want? But what if you are given a random random data from the user? You want to sort those things and then apply search techniques. So those sorting techniques are also required. Okay. Now, but how to sort? We'll discuss. I'll give you a minute to process this one and have your own idea on how to sort. Okay. Let me ask you one more question. Is the word sort is independent, or is there any ambiguity in the word sort? Compare elements, yes. Compare elements. I'll star this word. So is the word sort self-sufficient, or do you require more information to put the elements into order? Say, is it sort, but sort what? In what sequence? Yes, Astos, yes, you're audible. So the two there are some custom type of sorting also, but the two major sequences which we'll be thinking about is the ascending order and the descending order. Okay. So yeah, when you say sort, you have to say whether you have to sort it in an ascending order or a descending order. Okay. Even though it's a very, very simple term, just to be formal, we'll define what is the ascending order. Let's say A1 dash, you have these elements. you have some random elements. You have to arrange them such that your A1, A n dash, will be the most largest element. So basically, ascending order or say descending order, which we have, A1 dash will be greater than A n dash. Okay. These n elements, if you can permutate, there can be many sequences. Okay. There can be many sequences possible. Out of these many sequences possible, one sequence is an ascending order sequence, one sequence is a descending order sequence. For now, let's say that the elements are distinct. Okay. If the elements are distinct, let's take one small example. Let's take -2, -3, 10, 9. Okay. Let's say sort it in the ascending order. What is the ascending order sequence for this? Okay. -3, -2, 9, and 10. Descending order sequence. 10, 9, -2, and -3. Let's say my custom sort is sort by absolute values. I would expect the answer here, no? Sort by absolute values. Absolute values. So basically the mod value of it. So absolute value of -2 is 2, absolute value of -3 is 3, absolute value of 10 is 10, absolute value of 9 is 9. Yep. So it will be -2, -3, 9, and 10. So these are some ways of it. And sometimes you might need these custom sorts also. Okay. So yes, our languages, say C, C++, Java, any language, have inbuilt sort functions. But if you want to make tweaks like this, some ascending order sequence, some descending order sequence, some sort by absolute values, there are some other parameters which you can pass also. Okay. We'll discuss about those parameters and all those things later. Before that one, let me introduce one more term to you called as stability. What is stability? Okay, before going to stability, suppose I give you a sequence 1, 2, 2, 9. And I say there are two sorting sequences for this one. Let me reuse this. Okay. I have 1, 7, 2, 3, and 2. Suppose if I say for this particular sequence, there are 2 sorting sequences. Because the multiple occurrence, I'll say twos in the original array, 0th occurrence of 2, first occurrence of 2. When I sort, let's say 2 power 1, 2 power 1, 3, and 7. This is the first sequence. For the second sequence, I'll say 2 power 1, 2 power 0, 3 and 7. It might seem very ridiculous to say first occurrence of 2 and second occurrence of 2. Because both of them are technically the same sequence. In what order they are occurring, in case of a single array or single elements, it might not matter at all for us. Okay. But there are few cases where the sequence of occurrence in the original array also matter. Let's look at an example. So in C++, there is a particular data type called as a pair of int comma int. Okay, so basically it stores two sets of integers, 2 comma 3 or 1 comma 5, whatever. Okay, and you can also declare a vector of pair of int comma int. So basically what are you saying is, yours is, you have an, if it's an array of integers, you'll have integers. If it's an array of pair of integers, you will have a vector. In vector where you have each element is a pair of integers. So the C equivalent to this one is a struct. You will have, say, struct pair of integers, int x and int y. Okay. So the equivalent to a struct here is a struct with 2 integers is a pair of int comma int. There is a particular data type dedicated in C++. Suppose now the problem is you have some data which says you have some pair of data. Okay, it says you have 1 comma 5, 7 comma 9, 2 comma 4, 3 comma 8, 2 comma 5. This is x. This is y. Sort in the increasing order of x, and if x is equal, retain the sequence. Retain the sequence of original array. Okay. These x and y can be a train arrival, train departure, and in the data you want to maintain in the sequence of that, in the same sequence in which they are there in the original data. Then probably you will have 1 comma 5, 2 comma 4, 2 comma 5, and then 3 comma 8, 7 comma 9. Even if this particular 2 contains 5, this particular contains 4, then in that sequence only it has to exist. In problems, you might come up with situations like this. So this sequence in which they are there in the original data reflect the same in the output data also. Sometimes it's very, very useful. So make a note of it. Okay. Clear till here? Any doubts? Okay, Sachin says clear. Ashish also says clear. Okay, Ashutosh says clear. Rishabh also says yes. Okay. Rahul says clear, Rishabh says clear. What about Animesh? Animesh, Pranav. Okay. What about Jatin, Rashmi? Kapil, Ashish, Rishikesh. Clear? Okay. Correct. Ma'am, repeat once. Anish, any particular part you want me to repeat or in general? General report. Okay. So basically, searching and sorting constitute a very major section of our algorithms. Okay. While searching, there are two important things: your key and your search space. The behavior of your search space will have a lot of impact on the complexity of your code. Suppose if your search space is disordered, then you'll have to go to linear search, which will take a O of n time. But if your search space is sorted, it will take a O of log n time. For smaller inputs, the change is very small. But if you go to larger and larger inputs, the impact of the time complexity will decrease exponentially. So it is important that your search space is sorted. If the search space has to be sorted, what are the algorithms which run behind it? Okay, that's what we'll be discussing. Apart from the algorithms, in any language, there are inbuilt sort functions. Okay. So when you say sort, just not the sort, the order in which you want to sort is important. There are two very common orders: the ascending order and the descending order. And suppose if the elements are unique, there is only one particular sequence in which you can sort. Whether it's an ascending sort or a descending sort, there is only one particular way in which you can sort. But what if elements are equal? Suppose here you have two different occurrences of 2. It's 1 and 0. If you place first 2 first, there is one particular kind of sequence. There is one particular kind of sorted order. If you place the second sequence of first, then that's one kind of order. Numerically, there is no significance to these two different sorting sequences. Both are the same. But internally, in further problems, you might come up with problems such that you are given a pair of integers rather than a single array of integers. Each element is again a combination of two other elements. Suppose if you want to sort it in the sequence of the first element and say you want to whatever the sequence in which they have appeared, retain them in the same sequence. You might be faced with such situations. Then these duplicates will have an impact, because if we say just sort based on x and did not mention any condition on the second term, then this particular will have two different sequences. Okay, this can be swapped. Okay, because you have two different values. Here both the twos are same, so you don't have any problem if you change the order. But here both the twos are same, but the respective second values are different. So if you change, there is an impact on the entire sequence. There is an impact on data. So when there is such a then there will be an impact on the data. So it's important to it's sometimes very important to maintain the same sequence which has existed in your input data. So that's where these maintaining the sequence same as your original data is called as maintaining the stability of the data. Okay, say randomly, suppose if you don't follow this rule of stability, what will happen? There are two different things possible. Your data will become ambiguous. You say you applied sort function on this. You applied sort function on this state. Then you don't know in which kind of way your algorithm is sorted. Whether this 2,5 came first or 2,5 came at the second after 2,4. So it's when you have multiple things, it's always important to have some consistency follow the stability, which means that sorted based on x for remaining variables, follow the sequence which existed in the previous order. Is it clear now? Okay. Remaining people also, whoever have not replied previously. Okay, Kapil Kumar says yes. Okay, Dinesh also says yes. Cool then. Okay, just give me 1 minute. Okay. So as I have already mentioned, every language has a sort function. But how to sort? Or the order in which we want to sort, that will be sent by the user. Ashish, Vishal. Okay, cool. We are going to the next part. Sorting. How to sort? In which way to sort? We'll use that sort template, send it some extra input, send it some extra parameters, and get the output according to what which we want. Okay. So it's a sort. To sort, we send some data, and we also send a comparator function. That's the reason I said I'll start the word comparator. Okay. Apart from the data, which we'll also send a comparator. Why do we send a comparator? Because whenever you want to sort a sequence, think mentally how are you doing. Every time you keep comparing the elements. You have 1, 3. Okay, I said descending order sequence. 3 is greater than 1. Okay, let the sequence remain. Suppose I have 4 here. 4 is smaller than 1. So put 1 here, 4 here. Okay. So and when you compare, you generally compare 2 elements at a time. You compare 2 elements at a time. You repeat this process and finally come up with a sequence which is fully sorted. Do you agree with me? Just think on how you are processing given a raw sequence. How are you thinking? Okay, Sachin says yes. Are there any other people who are thinking it in a different way? Okay. What is happening? I don't see any replies. Okay, no problem. Do you all agree that this is one of the way in which people can sort? There might be many other different ways also in which you sort, but is this one of the way? Okay. We'll discuss different sorting algorithms later. But do you come up? But are you in line with me saying yes, this is one of the idea? Compare 2 elements always. Compare them multiple times, and finally you get a sorted sequence. Okay, great. Ashutosh also says yes. Ashish Sachin yes. Okay, cool. Hopefully, maybe other people are also in line with me. Is what I'm thinking. I'll proceed. Probably you'll get a better clarity on what I actually meant. Okay. So we'll go to C++. So C++ also has sort function for which you will be sending the beginning pointer of the array. Let me say V is my vector. Okay. Beginning point of the vector, end point of the vector, and you will also pass a comparator function to this inbuilt function. And in this comparator function basically returns true or false. According to the condition which you write here, this sort function will perform the entire sorting on this vector and return the sorted vector. This comparator function returns a Boole value. Compare, let's say, as of now we are solving integers, sorting integers only. You pass int y and x. Okay. You write some kind of code here and say that according to true or false, place them in the original sequence. What sequence? Okay. This comparator function, the convention of this comparator function is that if x is to be placed before y in the sorted sequence, then return true from comparator function. Read this statement very carefully. Okay? Right. These. X and Y can be X and Y can be any two elements in the array. They need not be in the order of occurrence. What do I mean by this? Suppose I have 1, 3, 5, 7. My x comma y can be 7 comma 3. It can be 3 comma 7. There is no guarantee that only 3 comma 7 will be sent to the comparator function. Okay. So even in the previous discussion when we are comparing, you want to compare 1 and 4. I can compare 1 comma 4. I can compare 4 comma 1. Mentally, I can do anything. Similarly here also. Okay. These two things are very important. Now, let's say we want to sort the sequence in the ascending order. Sort the sequence in the ascending order. Keep these 2 points in mind and write what you want to and how do we write the comparator function. Obviously, we have to write one if condition and say else. Suppose if this one I'll say return true, else I'll say return false. Let me know what I should write in that if condition. Think and answer. What I should write in this comparator function so that my entire inbuilt sort function gives me a sorted vector. I just have to write this one because my comparator function will take care of everything. What is the main function of my comparator function is that it will take 2 integers. If you want, if true is returned, x will be placed before y. If false is returned, if true in the sorted sequence, x will be placed before y. If it's false, y will be placed before x. Okay. I want the entire array to be sorted in the ascending order. What should be my if condition? Okay. X less than y, x minus y less than 0, x greater than y. Okay. If this condition is returned true, x will be placed first. In words, if x is smaller, because as I said, it's an ascending order. If x is small, then return true. So if x is small, return true. Okay. Is my condition right? Okay. Rashmi says yes. And just alone writing this function and putting this comparator function in the sort will give you an array which is sorted in an ascending order. This is the inbuilt function of C++. Okay, I'll give you 2 or 3 minutes to process this one. Once you understand, type yes. I'll be waiting for yes. Okay. If it's no also, tell me, I'll explain again. Because this will form a very, very core structure when you write your code. I mean, this particular 4 lines I would say in 60% of your problems, you'll use this part. So it's very important you understand. Let me know. This comparator function is inbuilt. Okay, so I would say like comparator function has some structure for it, but you can tweak the structure. What is a fixed structure? If x is to be placed before y, it will return true. Is it template? When to return, I mean, under what condition you want to return true, under what condition you want to return false, you can do it. This comparator function, the if and else conditions, you can tweak. But if the comparator returns true, suppose comparator takes input of two different functions. Perform whatever, let's say black box, whatever you want to write. But from this function, if you return true, in the sequence, I'll place x before y. If you return false on your conditions, I'll put y after x. This is what comparator knows. Okay. This is the template of the comparator. You can tweak this black box. Okay. Let's say, ma'am, take example and explain once. Okay. Suppose to the comparator function, my input is 3, 7. Okay. 3, 7. Now so basically my x is equal to 3, y is equal to 7. What condition did I write? If y is greater. Okay. So this is true. 7 is greater than 3. True. So it's true. It will return. If this is true, whatever sequence you have written, whatever sequence it has received, whatever x comma y it has received, it will return 3, 7. As we are passing this one as a part of a larger function, what it will do is, if you pass more integers, okay, it will return 3, 7. Okay, it will return 3, 7. Suppose if you have passed, let's say 3, 7, then your x is 7, y is equal to 3, condition is false. It will say, if you want things to sort in ascending order, the first element you have sent me, put it somewhere and put 3 here. In between, you might have many elements. This comparator function will decide this it's not the absolute sequence, but the relative sequence only it will decide. In that relative sequence, it will say that 3 should occur before 7. So we can get the condition in black box according to our case. Exactly. If you want ascending order, we'll write the black box according to the ascending order. If you want it in descending order, we'll write the black box according to the descending order. Okay. Let me take a larger example and let's explore once again. Okay. Let's say I have 1, 5, 7. Okay. Or let's take a very, very simple array so that you will understand. Okay. I have 5 and 7. This is the array which I want to sort out. I have written this comparator function, the same comparator function. If x less than, if y is greater, return true, else return false. Suppose the sort function to the comparator function, it has passed 1 and 5. If it has passed 1 and 5, what will happen? This is my x, this is my y. 5 greater than 1. What condition it is checking? X greater than or equal to y or not. Okay, this is my x, this is my y. 5 is greater than or equal to x, return true. It has returned true. True means what it will do is, okay, let me change this one. So it will say 1, 7, 5. Okay, it has returned true. True means my x value should be before 5 in the final sequence. That's what it will return. Now my function has sent 1, 7. Now what will happen? It will send 1. It has 1 and 7. 1 is greater than 7. It's true. So my 1 should also be after 7. So that 7 can be, that 7, maybe it said 1 is after 7. Only this condition it has checked. It has said, okay, true. Now let me send 5 and 7. Or let me send 7, 7 and 5. Now 7, 5. Condition is false. Condition is false means this my x has to be after 5. Okay, correct. Put it here. Remove 7 from here. It will send multiple combinations and finally decide this one as the sequence. Did the comparator function make more sense now? Okay. Kapil says yes. Dinesh says yes. Yes, ma'am, got it. Sachin says yes. Okay, cool. Ashish also says yes. Okay, I think Rashmit already understood. Kapil, I think I explained. Okay, cool. Take example. Dinesh also says example. Okay. Pranav also says yes. Okay, Chetan, good. Okay. So, this is something which I have used for illustration. Internally, whatever it might do, it will take the help of this comparator function. Comparator function just says this is the order in which we want. Still, treat your sort function as black box function. Comparator function, you'll just say whether it's ascending order, descending order, any other custom sort you want. Okay. In other words, in comparator function, you'll think your array has only 2 elements. If given 2 elements, how will you place them? Your sort function will observe this pattern. It'll increase. It'll apply the same thing on a huge array. Think in these terms. Is this clear now? So, in other words, comparator function is a smaller version of your sort function, which sorts 2 elements in the sequence which we want. Your sort function will take comparator as an example, and it will sort a larger sequence. Prabhojit says yes. And Rahul, Rishikesh, what about you? I'm spending more time on this because it's very important. From after, once I feel, ma'am, can we have a break? Sure. Sure. After this one, after this part is done, once we think that everyone has understood this one, we'll take 10 minutes break. Okay. What about other people, Rishikesh? Did you all understand? Okay, yes, ma'am. Okay. Rahul also says yes, cool. Lahari, what about you? Bishal? Okay, Bishal also understands. Good. Okay. Ravi Shankar also says yes. Good. Okay, then, if you understand this one, it's 343. Okay. 355. 355 will come back, we'll explore more on these things. Okay.
चल गया क्या खराब हो गया पूरा उसको चलाना मत उसको चलाना मत उसको अपने चलाना
Everyone back? Hello? Okay. 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 So we have written the comparator function for an ascending order set. What do you write if I ask to write a comparator function for a descending order set? What condition will you write? If some condition, return true, else return false. When do you place x above y? When do you say x will be in first and then y will be in the later sequence? I'm passing int x into y. If we return true in the sequence, x will be placed, y will be placed next, if it's true. When do we place? In under what conditions? In a descending order sequence, x should be placed before y. Okay. I'll wait for more answers. Okay, Sachin says x greater than y, Prabhojit says x greater than y. Any more answers? X less than y, okay. Okay. I'm happy that you are thinking, but let me explain this part again. The order which I want is a descending order. I'm passing int x into it. Y has to be placed. If I have to write a condition here such that x has to be placed before y. If it's true, x will be placed before y. If it's false, y will be here, x will be here. Okay. In a descending order sequence, x is greater than y. These x and y are any numbers. But if x is greater than y, return true, which means place x before y. Am I clear on that? In the descending order sequence, okay, Ashish says yes, Prabhojit also yes. Ashutosh, I think you got confused a little bit. Can you rethink and let me know if you got this point? Okay, good. No, nice. Okay. Can I replace all these if-else conditions and write to y? Return x greater than y. Can I replace this entire code with this statement? Because comparative operators return either true or false. True or false? Okay. Ashutosh says I can replace this entire statement with this one. What about other people? Do you think I can replace? There is no problem if you write the condition like this. There is no way. I have just returned this. I have written it like this because maybe yes. Okay. Yes, ma'am. Okay. I'm showing you this particular way because whenever you go to courts online or something, there might be statements written like this. So you should not get confused. That's the reason I'm explaining this part also. Okay. Let's see if we can write it or not. Okay. Suppose this is the descending order sequence which I want. I'm saying return x greater than y. If x is greater than y, suppose if this condition is true, I want my x to be placed before y. In descending order also follows the sequence. In descending order, greater element should be placed first. So if it is returning true, x should be placed before y, and that's what I want. If it's false, I want that to be in a reverse order. This itself is returning either true or false. I need not put separate condition and return statement. I can use this evaluating condition as directly in the return statement. This basically returns true or false. Basically, what I'm doing here is, if true, return true. Here, what I was writing is this one. If true, return true. So I'm just a multiple comparisons. So instead of doing this multiple comparisons, I'm saying use a statement directly. Rashmit, is it clear now? Okay, great. And again, I'm repeating, there is no problem if you write the conditions like this. It's perfectly all right to write your comparative function like this. Okay, awesome. Let me ask you a simple question. Let's do one more question. Okay, you are given a vector where element in each vector is a pair of integers. Okay, you are given points, but in fact these points are the coordinates of your 2D space. Okay, now sort them in the increasing order of their closeness to the origin. To their origin. Or in other words, again, what are the k closest points? K closest points to the origin. Points to the origin. So basically, after sorting your array, your first k elements have to be something which are closest to the origin. Think and let me know. Change the pair of array into simple array. Distance of a point, then sort out. Good. Create a new array with the distances and sort array in ascending sequence. So what is the distance formula? will it be, so to access values, we'll suppose if you have pair of int comma int with variable name p1. To access the first integer, you will access using p dot first. To access the second element, you will use p dot second. Okay. So can the distance formula be p dot first square plus p dot second whole square? Yes or no? Okay. Okay. Done. So in this approach, we are using distance, sort as two different things. We are using O of an extra space. Okay. Can we add this distance in the comparator function itself? Function itself. Let's say a bool operator. I have a comparator function. I am saying you'll receive a pair of int p1, a pair int comma int p2. If some condition is satisfied, return true, else return false. Think and say me where I have, what condition I have to write here.
सुरक्षा के लिए कैसे बॉर्डर पे तैनात रहते हैं, तभी तो इनको बीएसएफ के नाम से जाना जाता है, बॉर्डर सुरक्षा फोर्स। और इनकी इस काबिलियत को देखकर अमित शाह और देश दुनिया के लोग दंग रह गए कि अगर देश की सुरक्षा में इनके रास्ते में कोई बाधा आ जाए तो ये कुछ ही मिनटों में उसको दूर करके कैसे देश की रक्षा के लिए निकल जाते हैं। जी हां, इन्होंने कुछ मिनटों में बीएसएफ की कार को ऐसे खोल दिया कि मानो ये कार उनके सामने कुछ भी नहीं है। और ये देखकर सब
One small hint is
देखते ही देखते इन्होंने इस कार को 47 सेकंड में वापस छोड़कर देश और दुनिया को चकित कर
in my sorted sequence, if distance from origin to P1, if this is less than distance to P2, then P1 has to be placed before P2 in the sequence. This is the hint. According to this hint, write the equation. In words, can I say P1 to origin distance, if that is greater than P2 to origin distance, then can I, in my original sequence, I want P1 to be before P2. That's it. Distance of P1 to origin, distance of P2 to origin. Okay. Now, what is the distance formula? Distance formula is P1 first whole square plus minus 0 minus 0. I am discarding that one. P1 dot second whole square root. I can. I want to compare this one with square root of P2 dot first whole square plus P2 dot second whole square. Both square roots I'll know just for my easy computation. Okay. Then just refining and rewriting it again. Bool comparator function. You will receive a pair int comma int P1, pair int comma int P2. Your job is to compare these two functions, and if my P1 distance, P1 dot first from the origin plus P1 dot second whole square is less than P1 dot first whole square plus P2 dot second whole square, then return true. Return true. Else return false. By returning true, what I'm saying is place P1 before P2. You don't need just this relative position. In between, after, before, any other elements can come. Okay. Is this clear? In comparator function, you're putting condition on the internal elements, but what are getting sorted are the elements. You can manipulate these conditions also. Internally also you can manipulate and arrange the elements. Okay, Ashutosh says clear, Rashmi says clear. What about remaining people? Ashish also says yes, good. I'll wait for 2 minutes. Okay. I'll wait till 4:14 for you to process these things. Try to understand what happened, how powerful the comparator function can be.
क्या होगा चाचा इस बार जो है बीजेपी आएगी। क्यों ऐसा लगता है? विकास के नाम पे आएगी, विकास की और कानून व्यवस्था और सड़कें भी बढ़िया है और विकास के नाम पे काम करे हमने।
Okay. What about Animesh, Rahul, Dinesh? Okay, Rashmi, Suraj, Prabhojit, Rishikesh, Kapil, Ravishankar, Lahari, Pranav. What happened? Did you understand? Rahul says got it, ma'am. Rashmi, clear. Okay. Animesh, Lahari. Aniket, very dull today. What happened? Prabhojit says. Good. Okay. Prana, Anish, what happened? Got it? Okay, Kamil says clear. Sparsh also says clear. Anish is fine. Dinesh is fine. Cool. Great. Awesome. Let me give you a quick question. Okay. So, question now is again a vector with pair of integers is given. Okay. Sort them in the sort them in the increasing order of first element. If the first element is equal, then sort them in the decreasing order of second element. Solve using a comparator function. Comparator function. I'm sending pair of int comma int p1, pair of int comma int p2. What are the conditions? I'll slowly start filling it. I expect some answers on the chat, okay? If p1 dot first not equal to p2 dot first, both the first elements are distinct. If both the first elements are distinct, what to do? Sort them in the ascending order. What condition should I write here? In any way you can use. Else you can use else if, whatever you want, your choice. I'll try to write the simplest version of it. That's it. Let's say if both the elements are not equal, I want them to sort in the descending order. Then I'll say p1 dot first. If it's less than p2 dot first, if p1 dot first is less than p2 dot first, then place p1 before p2. That's what the first condition was. Sort them in the increasing sequence. If p2 dot first is greater than that one, put it later and put p dot first. Yes, right. Excellent. Yes, Rashmi, you're right. Else what I should do? Sort them in the descending order of the second element. Then I'll say return p1 dot second, p2 dot second. Okay? So basically, if p1 dot first is greater, then place p1 first. Because I want that to be in the descending order sequence. Basically, I have removed two if-else conditions. I have simplified the answer to be. Give me 1 second. Where did we write? Where did we write that function? Yes, this one. So this entire condition, I have simplified it to one statement. That one single statement only I have used in my further works. This entire thing, I wrote it in one line here. For the descending order, this is one piece of line. The same piece of line I've used it here. But with changed condition. Everyone understood this one? Yes or no? Okay. Asha says yes. Rashmit also says yes. That's good. Okay. Sachin also says yes. Dinesh says no, ma'am. Okay. Okay. Let me re-explain. Dinesh, did you understand this part? This one. I'm about to sort this one in the descending order. If I have to sort in the descending order, what will I do? X. I want my, if x and y, if x is greater than y, I want x to be placed before y. So, my comparator function, if it returns true, then x will be placed before y. In true condition, what I write, if x is greater than y, return true. Else return false. I'm using two if-else conditions here. But the comparator operator itself is an operator which receives either true or false. So I have used a direct condition, x greater than y, return true. X greater than y means if this comparator function is returning true, x will be placed first. When I want x to be placed first, when x is greater than y, I want x to be placed before y. Dinesh, is this part clear? Or not, Dinesh, in general? Yes, got it. Okay. This function. This is for descending order. Now, okay, let's come back to our question. What's our question? I'm giving a vector which contains pair of integers. So basically the vector will look like 2, 3, 5, 1, 5, 1, 6, 8, 10, 1. So this is how the vector will look. I want to sort this one. In how do I want it to sort? Sort them in the increasing order of their first element. So I have 2, I have 5, I have 6 and 10. Okay. Unfortunately, this is already in the sorting order. I want to sort them in the increasing order of their first element. If the first element is same, suppose I have two things, 2, 1, and then I have 2, 2. I have two elements first. Then, if as these both elements are equal, I'm putting a condition on the second element. Sort them in the descending order sequence. Sort them as 2, 2 and 2, 1. Remaining elements will be remaining elements only. When the first elements are same, use the second elements as a tiebreaker. And what is the condition on the tiebreaker? There has to be a descending order sequence. So let's look into that. What to do? I have passed two pair of increments. Suppose if the first elements are not equal, our condition is very simple. Sort them in the increasing order sequence. In increasing order sequence means if my P2 element is greater than P1 element, I have to return true. If it's returned true, P1 will be placed before P2. That's what the condition which I want. And then, if both the elements are equal, then use the second element as a tiebreaker. But now, write the descending order sort condition for this one. Here I wrote the ascending order sort condition. Here I wrote the descending order sort condition. Understood. Okay, great. So, now can you think how important comparator function is? Here I have made two comparisons. If each thing has n elements also, however you want to sort, you can just write these conditions and sort the sequence. You need not think about any sorting algorithm. Okay. So will everyone go and experiment with the comparator function? I'll give you two homework problems. Okay. One homework problem is stability. We have discussed about stability, right? Just given one integer vector, how will you maintain the sequence of occurrences also? I mean, how will you maintain the order? Okay. Maintain the order. How will you maintain? Okay. hint is create vector with pair of integers. Okay, create a vector with pair of int comma int. This pair of int comma int, first integer has to be ARR of I and second integer has to be I. Now you know if 2 has occurred 0 time, 1 time, 0 at index 1, suppose. Now you already know for pair of int how to write the increasing and decreasing conditions. Write those conditions and sort that. After sorting, the first elements of all the pair of vectors will form the desired order. I have almost answered the question, but I want you to implement this. Okay. Homework, this is problem 1. Second problem. You are given 2 strings. Okay. S is equal to ABC. T is equal to ABCD. It is guaranteed that S has distinct characters and obviously less than or equal to 26 only. Now, sort T such that the elements are in order of S. Okay, let me tweak the example a little bit. CBA. Okay. If anyone understood this question, what should be my answer? Answer this one. If the particular character which is there in D is not there in S, it can be placed anywhere. It's your choice. It's your choice. What will be the final sequence of T? Answer this one, then I'll understand whether you have understood the question or not. If not, I'll repeat the question again. Okay. Right. In what sequence characters have appeared in C, the same sequence characters should appear in T also. Did not understand question. Yes, I'll repeat that. S has some sequence of characters. The final order in which the letters appear in T should be in the same order as S. Basically, it has CBA. So if C is there in A, place it first. B is there, place it first. A is there, place it there. I have D. Now D can be placed here. You can place it at the start or you can place it at there. I leave it to your choice. Place it anywhere. Now did you understand the question? Okay, great. Solve this one. This question can be solved just using the comparator function. How to solve? Think. Solve it as a homework problem. For this also I'll give hint. In the previous problem, we have used index. Can you use index here also? For characters which are present, use index. If characters are not present, use some value. Now let's say suppose you have a vector A, B, C, D, so on, so on. You have rankings 1, 2, 3, 4, like that. You want to sort it. You have passed 2 characters, character A, character B. You have passed character A, character B. In the comparator function, can you write something on the lines? Compare rank of A, rank of B, and then try to sort. I have almost given the answer. Let's suppose this is the rank array which we want to use. Making use of this rank array, can we sort T in our desired sequence? For both the questions, I have given hints. Okay, let me ask quick questions. Ma'am, convert in ASCII value, then sort. Your rank can be anything. Converting into an ASCII value, very good idea. Appreciate that you're thinking, you're able to connect different concepts. That's very good. Your rank can be 1, 2, 3, 4. Your rank can be 1, 2, 3, 4. It can start from 28, or it can start from ASCII value also, because ASCII codes are sorted. End. Maybe you can just say ASCII code of A, ASCII code of B, and then compare. But here ASCII codes will not work, because this particular S sequence, this S could be in any sequence, not just in the ASCII sequence. But yes, this ASCII sequence, if you want to directly sort, you can use ASCII code. Yes, very good, Sachin, very good. For direct sort, you can use ASCII codes. But you are kept under restriction that you have to use the sequence of yes, you have to create your own rank array and then manipulate. Okay. So, did you understand the question and the hints? If yes, type yes. If no, type no. Okay, Sachin, Saurav, Ashish say yes. What about remaining people? Pranav, okay, Rashmi also says yes. Good. Pranav, Ashutosh, Saurav, Lahari, Dinesh also says yes. Pranav says yes. Rahul says yes. Good. So, by tomorrow, can I expect you to solve these 2 questions? Tomorrow, at the start of the class, I'll ask whether you're able to solve these functions using comparator function or not. Okay. If you want to check the syntax and all those things again, you can go you can search for any C++ reference. You'll find the comparator operations. But if possible, I have an immediate meeting at, I think after at 5:30 or something. I have a meet. If I don't have any meet, I'll send you a template. At least for ascending order, I'll send the template. From that one, you can use the template and work on remaining things. Okay. If I don't have a meeting, I'll immediately send. If I have a meeting, I'll send it after some time. Meanwhile, you can keep trying. Jagadesh says yes. Okay, good. Okay. That's it about the comparators and the inbuilt functions. But okay, before discussing, do you already know any sorting algorithms? Like without using comparator, are you aware of any other sorting algorithms? Based on the pace of the class, I'll discuss at what speed I have to teach today. Ashutosh, yes. If yes, what algorithms do you know? Bubble sort, bucket count. Okay, Kapil Kumar says no. Okay. Merge sort, okay. Merge selection, bubble, insertion, bucket. Great. So I had discussed the comparator first before discussing the algorithms because I thought this comparator is relatively new to you, and introducing them as a part of C++ and DSA course would be more fruitful than discussing the straight up algorithms. I'll discuss the algorithms also. Okay. So I see few people knowing few kind of algorithms, but whoever knows, it will be a recap. Whoever does not, they'll learn these algorithms also. So I'll proceed with the algorithms now. So we have discussed comparator function, and we said that okay, there is some inbuilt sort function which is happening inside. But what if we were asked to write our own function for sort? Our function for sort. Okay. Let's see different kind of sorts. Coming to the first sort, its name is called a selection sort. Okay. Before we discuss any sort, I'm giving you a books, 10 books, 10 different sizes of books. How will you sort it? No C programming, nothing. Your task, book with different sizes. I asked you to sort. How will you do that? I asked a very general question. In general, how will you sort? Given books, how do you sort? Suppose you have ascending order, take the smallest one, then the second largest. Jatin, how Jatin answered, I want you to answer it that way. One idea is, okay, one general thing which comes to our mind is take the smallest, next to search for the next to smallest, next to search for the small, next to smaller one, so on. Finally, you'll get the sequence. Okay. Any other methods? Lalit says ascending order. Yes, ascending order. I think you meant take smaller one first, next smaller one, next smaller. Can we do it in any other way? How do you generally do? Vice versa. That's also true. We take the most largest, then next to largest, so on, and then also you will get a sorted sequence. Finally, a sorted sequence. Okay. Any other methods? Take one and put it into the right position. Yes. Put it in the right position. So imagine this is similar to sorting a deck of cards. Suppose when you play rummy or something, when you have 4 and 6, say suppose you get a 5 card, what will you do? You insert that between 4 and 5 and try to make it triplet 5. So that's one way of sorting. Any other ideas?
Hello.
Can we use the divide and conquer technique? No, ma'am, all are done, I think. Okay. Can we use the divide and conquer technique we have? Suppose you say, I already have one sorted sequence. I already have one more sorted sequence. I want to make a sorted sequence of both these things. Yes. Okay. I sort a smaller part of it. I sort another smaller part of it. Now I merge these two sorted parts. Okay. So all the algorithms which we write or anything are basically our, say, real life tasks only. So basically, when you have a question, think how, as a human, how do you do it? Then obviously you will be able to reach the algorithm. Okay. So these all the four techniques are given names. That's it. Nothing other than that. The smaller one is called as a selection sort. This largest one is called as a bubble sort.
Hello.
And take and insert is called as an insertion sort. And taking two parts, sort them individually, merge them is called as merge sort. There are many other sorting algorithms also, but the core ideas of the sorting lies, I personally, my choice of four good algorithms of sorting are these. So we'll discuss these four. Step by step, we'll discuss. Probably just with this idea, you should be able to think about code also. I mean, if you spend 5-10 minutes, probably you'll easily write a solution for this. Okay, till here, was I confusing? Was it okay?
Hello. Hello.
Okay. Selection sort. What do we do in selection sort? Pick minimum. Pick minimum. Place it at the start. Place it at the start of already sorted part. Sorry. Place it at the start of unsorted part or end of sorted part. Okay. Place it at the start of unsorted part and then repeat the process. Repeat the process till you sort the entire array. Okay. In other words, what happens is at every instance, a part of it will become sorted. In the remaining unsorted, pick minimum, place it at the start. So the sorted array size has increased. Now this part is unsorted. Pick minimum, place it here, close the things. Okay. I'll write a brief code for this one also. For I is equal to 0 to n minus 1. So this I is nothing but the index which we are going to set it right. What we have to do, we have to search for minimum element also. Minimum element in the remaining elements. As of now, let's assume that our minimum element is at index I only. The current index is only the minimum index. Assume this one and iterate for I plus 1 to n minus 1. Searching the remaining part of the unsorted array. It's not n plus 1, it's n minus 1, n minus 1. If you feel that AR of this current element is less than the element which we assumed that it is the minimum index, then change the minimum index to this element. Change the minimum index to 0. Okay. After changing that minimum index, after this for loop iteration is done, swap the elements. Swap the elements of minimum index and swap the elements at minimum index and ith location. Basically, the ith location is the one which we are going to in the sorted array. What element is present at ith index? After one iteration of this for loop, we want that element to come to that position, and we do it sequentially from 0 to n minus 1. Okay. Any doubts on the code?
ऐसे प्लेसिंग क्या था इसका ऐसा से होने का
Okay. What is the time complexity if there are no doubts?
वो आया नहीं था 24 से ज्यादा हो गया
What are the time and space complexities? One loop, this is an n loop. For every n loop, in worst case, you might run this one n times. For each n, there are n other different things happening also. So it's actually n square. Suraj, Lalit, and Dinesh. Is it clear now? I mean, you might have got confused a little bit. Okay. Ashish says n square again. Okay, that's cool. Dinesh and Suraj. Okay. Done. What is the space complexity? I'm waiting for space complexity answer. Yeah. Yes, it's O of 1. I'm just using one more variable called as min index. Apart from that, I'm not doing anything else. Okay. So selection sort is done. It is the simplest of all. So now let's go to bubble sort. Okay. Bubble sort, what we do is we compare adjacent elements always. Okay. Compare adjacent. So for all the algorithms which we discuss, as of now, keep in mind that by default we are doing an ascending order. Okay. So compare adjacent elements. If the sequence is not in the order which we want, swap. Else don't swap. Then swap. Else don't swap. Okay. So we start the comparison from 0 and move till n minus 1. Okay. Think for a moment. In every iteration of bubble sort, what happens is the largest element will go to the end. Okay. Let's take an example. Let's say our example is 2, 7, 8, 3, 1. Okay. For my first iteration, what I'm doing is 2, 7. I want it in the ascending order. Yes, they are in the ascending order. 2 is greater than 7. Good. No need to do anything. 7, 8. They are also in the ascending order sequence. I am not repeating anything. 8, 3. 8, 3 are not in the I want my final sequence to be 1, 2, 3, 7, and 8. In the final sequence which I want, 8 is after 3. So swap these two things. Swap and make them 3, 8, and 1. Okay. Now compare 8 and 1. Again, both are not in the 8 is greater than 1. So swap again. So 2, 7, 3, 1, and 8. So after one iteration, after we move from start to end, after one iteration, the largest element will go to the last index. And that's what we want. And from now on, we'll repeat our algorithm on this end. 2, 7, swap, 2, 7 is fine. 2 is smaller. It's okay. I'll say after first iteration, these two elements I'm comparing. No need to change. I have 2, 3, 1, and 7. Now I'll compare 3 and 7. They're not in the sequence. So I'll say come 3. 3 should be here, 7 should go there. And 1. 8 is there. That's already in the desired position. I'm not going to touch that again. Now compare 7 and 1. They have to be shifted again. 2, 3, 1, 7, and 8. Now, after the second iteration is done, you have two last two elements in their sequence. Repeat for this one. Repeat for the smaller part. Repeat it n times so that n elements will come to the sequence. Will come to the desired positions, in other words. Algorithm is clear? Okay, Ashish says yes. What about remaining people? Anish also says yes. Falak says yes. Okay, Kapil also says yes. Let me write a small, let me just write a pseudo for this. For I is equal to 0 to n minus 1. Okay. And for j is equal to 0 to n minus I minus 1. So basically this loop is saying however how many iterations have already happened, how many iterations have already happened. Till there, don't do our operations. We are fine. We are good with that. Don't go and compare those things. For this particular loops, what it is saying, if ARR of j is greater than ARR of j plus 1, then swap these elements. Swap j and j plus 1. When I mean swap j and j plus 1, the elements at index j and j plus 1. Continue this process till it exits from both loops. Then finally you will get a sorted array. Clear? What are the time and space complexities of these algorithms? Yeah. The outer loop is for n iterations. For each iteration, in the worst case, you might go till n iterations for this one also. There might be n iterations, and there might be a case every time you have to swap. Okay. So time complexity will be n square. I'm not using any other extra space. Space complexity will be O. So, okay. Do you want me to stop or shall I explain insertion sort also? Stop. Okay. What about remaining people? Do you want me to stop or continue with the insertion sort? Enough for today. Okay. I'll stop for today, but promise me these two things, that you'll code up these two problems. One problem where you have to sort based on indices is also the second element, the repetitive elements one, and sort T in the sequence of S element sequence. Can you name the topics today's covered in class? Okay. So we have discussed about we have discussed the subarray problem, how to generate subarrays, but as a homework I've given you subsequence. Okay. So these are basically the applications of recursion. And then we were discussing sorting techniques. While discussing sorting techniques, we have discussed about comparator function, and I've given 2 problems as homework. And then we have discussed general sorting techniques also. We have discussed about bubble sort and selection sort. Okay. Tomorrow, what we'll do is, for a little bit of time, if you have any doubts, we'll spend time on that one. Okay, my pen also wants me to stop. It's done with its charging, I guess. Differences between subset and subsequence. Subset, okay, it'll take a little time for me to explain. Let's do it tomorrow at the start of the class. I'll do Ashutosh. That's very, very close, but just that it's a naming convention only. But clearly, I'll explain it tomorrow at the start of the class. Remind me tomorrow. Okay. Okay. Tomorrow, if there are any doubts, we'll discuss those doubts. Then we'll discuss insertion sort and we'll discuss merge sort. Once we are done with this one, we'll move to linked list. It will be a different new data structure. We'll move to that part. Just for a heads up, how many are already aware of linked list and problems on that one about it? Already know about the data structure and stuff. No, ma'am. Okay. Little bit, ma'am. Only know about the concept. Okay. The concept of linked list is very, very small. Let's discuss, today also, actually technically today I thought we'll be able to complete insertion sort and merge sort also. But it's okay. It's important that you understand and get the things rather than rushing over. We'll discuss few problems on linked list. So, but if I have to discuss new concepts, at the same time, you have to keep doing the questions which I say homework, do this question, keep doing those questions, don't lose that. Definitely the problems which I mentioned today, the T or S, I would have written it on the class, but due to the time constraint, I just had to give the hints and ask you to solve. At least I would have solved the string question. But yeah, I think I gave almost I completed the entire idea. The only condition is what I left to you. Okay. Okay then, if you have any doubts, you can ask. Otherwise, you can leave. If you don't have any questions, feel free to leave. And just a quick feedback, how was today's class? Was it fast, slow? Should I slow down the pace? Should I increase the pace? Okay. No. Am I audible at least? It was good. Okay. great. Yeah, please let me know if it's slow or fast. I mean, based on your input only, I can adjust the pace of the class. So it's important that you let me know when the class is slow or fast. Okay, cool. Okay, then it would have been a tiring 3 hours. I'll end the class. Bye. Have a good day.